This episode of Worked Problem will be focusing on a question that involves a limiting reactant situation in a fully gaseous state. So let's take a look at the question. The question says that 2 moles of hydrogen reacts with 1 mole of nitrogen were introduced in a volume of 22.4 decimeter cube vessel, and they gave us the temperature to be 273.15 kelvins. They've given us a reaction, and the reaction is balanced. They ask us to calculate the total pressure exerted by the gas in the container after the reaction goes to completion. Now let's take a look at this term, after the reaction goes to completion, because this is a very important term for us to understand what are the elements or compounds that will contribute to the total pressure. For visualization, I'm going to just draw a closed reaction vessel to which we visualize the production of ammonia as pink particles, which is our product. Alongside with that, we also have hydrogen in green, and we have nitrogen in blue, light blue. Okay, so when the reaction goes to completion, we need to ask ourselves, will there only be ammonia gas in the reaction vessel? Or between these two reactants, will there be any remnants of the reactants that is left? This comes into question whether we will be dealing with a limiting reactant or an excess reactant in this case. And how do we know and able to calculate if there is a limiting reactant or excess reactant involved? The question has given us the moles of both reactants. Now, in a situation where the moles or the amount of both 2 or more reactants are given, this allows us to decide and determine which reactant controls the entire reaction, which means we are able to calculate our limiting reactant. So let's get started. We write down the chemical equation and the necessary information underneath the respective elements or compound. 1 mole of nitrogen and 3 moles of hydrogen. Since the amount is already in moles, and that's the right unit for us to proceed with a mole ratio step, we move straight into a mole ratio. So the mole ratio formula, moles of known, in this case I'm going to be first speaking about hydrogen, divide by coefficient of known, multiply by coefficient of desired, which is the coefficient of ammonia. I will get from this 4/3 moles of ammonia that's produced. So what did I just do? I did a comparison between hydrogen and ammonia. The second comparison will be between nitrogen and ammonia. I repeat the same mole ratio step, starting with my moles of known. Known in this case is nitrogen, divided by the coefficient of nitrogen, multiply by the coefficient of desired, which is ammonia. And what do I get? I get 2 moles of ammonia. Now the mole ratio step can be done just by this step. You need not include the coefficient of the desired, or you can go full, meaning you can proceed to calculate the moles of your desired. So in this case now, once we have calculated, we make a comparison between the both moles of desired, and we realize that this is smaller. Hence, the limiting reactant now will be from hydrogen will be the limiting reactant, and nitrogen will be my excess reactant. So we can confidently say that the moles of ammonia will be limited or constrained by hydrogen because it will finish first. meaning our maximum number of moles of ammonia will be produced by hydrogen. So I write the moles of ammonia. Now next up, we calculate excess reactant. The formula or the strategy is to know the approach. We start off with the moles of limiting reactant, which is 2 moles of hydrogen, divide by the coefficient of the limiting reactant, multiply by the coefficient of the excess reactant. We get 2/3 moles of nitrogen used. What we need to calculate is what's left. So how do we do that? We start off with the initial moles, which is 1. In this case, since I'm working in fraction, I represent 1 with 3/3 minus 2/3. 1 is used or 1 is consumed to get 1/3 moles of nitrogen left. So this is an important number because it will contribute to the total pressure in the reaction vessel. What do I do next? I plug it into the ideal gas formula. PV equals to nRT. Since I'm calculating pressure, my manipulation will be nRT over V. My N now can be a summation of ammonia and nitrogen. That will be 5/3 moles multiplied by my gas constant, multiply by the temperature, divide by the volume. In this case, it was given as 22.4 decimeter cube. Solving this will give me my final answer of 1.67 atm. This is the pressure that's produced when the reaction goes to completion, meaning it's contributed by 2 elements or compounds, which is nitrogen, which is in excess, as well as ammonia.